What we've done with the Rapid IoT Developers Kit is really provide you a living triple play experience. It provides not only the Telit hardware that you start out with from the development perspective and the board associated with it, but then also the cellular data plan, as well as the cloud provisioning as well, or the cloud platform. So in one easy sweep, you open the box, you've got all of those things at your fingertips to get started, so you don't have to go through the provisioning cycle and the delays and everything associated with it. So that's what our goal was with the actual IoT Developers Kit. What's in the box, like I said, the cellular plan comes with it. We're actually going beyond that. We're going to have pre-provisioned platform orgs with pre-provisioned things and thing definitions, if you're familiar with our platform, to where it's really, truly plug and play. I challenged myself to take the parts out of the box, brand new, start to finish. Of course, I've done this a few times, so it's unfair, but I did it in 12 minutes. So, and that's literally from a box I'd never opened or cut the tape on. So it can be, can hopefully be a very good, fast-paced experience. But what we've tried to do is provide you everything you need to get started without having to go start finding sensors, figure out, am I going to use a SPI bus? Am I going to use I2C? Am I going to do something with a TTY or, TTL interface? The board itself comes pre-assembled and configured, multiple potentiometers, push buttons, as well as an entire I2C network on board with different types of 6-axis MEMS types of sensory component on it as well. And we'll go into that in a little bit more detail. There's Telit technology on both sides of the board. Top side, obviously, we have the cellular module. What you see here and what's available during the session this week at CTI is HE910 based, so you'll have capabilities to take advantage of that at 3G. We also have LE910 technology available, and the LE910 V2 will be probably a strategic module on board, so you can pick which carrier you want support for and move in that direction as well. On the bottom, you'll see we've also have Telit location technology, so that if the module that you happen to be using or you need more advanced location technology, you have the circuitry right there. You don't have to go find it or add it externally. So, quick laundry list of the features. The potentiometers I mentioned, the push buttons. You have 6 LEDs on board. A couple of those are tied back to the module for status and power and things of that nature, but the others are available for programming. You have also, we provide a lithium-ion battery with the thing and the charge circuit and monitoring circuit as well, another I2C device on board. I'll go into that more in a little bit, but it's all there. The battery comes along with. For smaller pets and things of that nature. The accelerometer and gyroscope, that's all integrated into an ST Micro module, one of their more advanced MEMS modules. We'll go into detail on that in a little bit as well. Temperature sensor, both inside the MEMS module as well as on the Telit module for internal temperature. And we actually had 2 other temperature sensor points as well in the different I2C devices on board if you want to get to them. 9-pin serial, so if you still need some type of physical serial or 232 interface, it's already there. You don't have to worry about going get a level shifter chip and doing all the work you typically have to do to make that happen. As I mentioned, the 2 Telit modules for cellular and GPS. Right now we're using a standard size SIM, whether it's LTE or 3G, just pop it in for the module that you're using, you'll have what you need there. And then I think one of the things that sets this board apart from everyone in the other one in the industry is that we've developed or designed in support that not only this module can be a standalone device where you can deploy in a standalone mode, but also it has the capability to support the standard prototyping platforms like Raspberry Pi, like Arduino, and like TI Launchpad. So I'm going to take you through those details and how that integration actually happens as well as we go through it. So you basically have 4 modes of implementation and also the capability to very quickly change between them. Once you buy the board, it's not like you're locked into any one of those configurations. You can use Arduino in the morning and Raspberry Pi in the afternoon. It's your choice how you want to go about working with them. Here's a quick rundown of a little bit more of the details, not because there's going to be a quiz at the end of the session or anything, but basically, like I said, we've made jumpers so that it's very simple to change between the different configurations, as well as the capability to address the different hardware and components on board. Reset button to reset the module. You'll notice there's both cellular and SMA connections for both cellular and GPS. Most of your connection for your programming is going to be over the USB connector as well, so the mini USB is used for that. I would say the biggest single thing to note, though, is you'll see the banks of headers. Here for your classic your classic Arduino. Here for your TL Launchpad, and then you get into the bank over here for your Raspberry Pi. So it basically gives you very easy. You can put them on top. You can put them on the bottom. Build that out. Like I said, the location capability and all is there as well. And again, the headers are duplicated here as well so that you can have the boards either side, top side or bottom side. And that was actually no small feat of engineering, because we had to make sure that there was no component interface challenges and things of that nature. The team did a very good 3D modeling analysis of this to be able to make that happen. Now, integrated on the board, as I mentioned, are several sensors that are I2C in nature. You can take advantage of those. What we're doing in the software that you get is we basically expose those all as library calls, so you don't really have to understand the details of I2C, but if you want to, the source is all there, so you can crawl down into it and understand how it all works. Accelerometers, gyroscope, temperature, battery monitor, all built in. And these are the different details if you happen to want to know, what's there. The top two, let's see, this guy probably has laser. Yeah, the top two units, ST Micro, that's the NEMO LSM60S3 inertial module. So you've got both accelerometer and gyroscope in there, as well as temperature available to you. And then from a standpoint of the actual battery monitor, is the ON Semiconductor LC709 module there. So they provide very nice, effective interfaces, but the way you see them on your Raspberry Pi or on your Arduino is simply an API call. So it makes that much easier. The ST Micro, both the MEMS sensor here and the high accuracy humidity monitor, we initially had those on board. What we're looking at doing now is possibly making some other configuration available to you, like maybe we're going to have a luminosity sensor, a proximity sensor, things of that nature that may provide a little more flexibility for how the board's used. So we'll see how that goes forward. Like I said, one of our challenges in the world that I deal in, kind of week to week, is the calls coming in saying, I'm prototyping this thing on a Raspberry Pi, or I'm prototyping this thing, on an Arduino or a TL Launchpad. So we realize those are common deployment platforms, but people are forever having to go do, jumper wires here, there, and the other, and use breadboards. And we wanted to say, okay, how are we going to make this an easier, simpler experience? And that's really kind of where the birth of this thing came from. If you know Telit has had many generations of evaluation kits. The original evaluation kit, the second generation EVK-2, which you're probably very familiar with the different modules and the riser cards. Then there was an EVK-3, which was for our location products. The EVK-4 is all about IoT and packaging that IoT experience so that it's quick and easy and enjoyable and productive. Again, lots of different open platforms for it. You can use the Raspberry Pi Zero, you can use the Raspberry Pi 3, you can use the 2s and all as well. If you are going to use obviously the Pi 3, those of you who are very tied into Raspberry Pi, you know that they've kind of stolen your UART serial channel off the header and given it to the Bluetooth LE chip. So you'll probably need to remap that if you want to use the RS-232 port, but still the capability's there. So you basically have the capability to bring them together. They mate. It gives you a very nice, clean assembly, whether the hardware is going to the top side or the bottom side, so that in the end, you've got a very nice interface. All of your programming then is done right there in either Energia, if you happen to be a sketch-type programmer for TL Launchpad, or if you use Code Composer and do everything low-level native, we have support for you to go either way to work with the modules. And here's the same type of thing, but with an Arduino. Either large form factor or small form factor Arduino connectors are there as well. So, and then of course your Raspberry Pi comes together. This happens to be a Pi 3 in this particular scenario. So we do have some blocking on one of the actual standoffs on the USB ports. There's still 2 available. And if you have to work around that, then you can work with that as well. But just as a physical interface, they, with the move from the 2 to the 3, we endured that. But again, once that board is mounted, you have the full capability to work with Raspberry Pi, whether you're programming in Python with the Python interpreter, or programming in C with the C toolkits, or the integrated new compiler that comes on the Raspberry Pi. Or if you're a DeviceWise user, we have full DeviceWise support for it as well. You load up your DeviceWise, there's drivers that realize it, and now you can control all your I2C and whatnot through your standard driver interface on DeviceWise. But it's really all about the experience. I mean, that's kind of what we wanted to do. Whether you're children, this happens to be the Chicago IoT, children's gathering. I don't know how young they start there, but it's focused on IT, or grad students or projects that they're working on, or professional engineers working on a project. We wanted to provide a very fast, efficient, easy to use experience that would guarantee a level of success, let you focus on your app, not all the plumbing that you have to do. So to make that happen, there's a lot more to the kit than just the physical hardware and the software that runs on it. We've put a lot of information in place. These are obviously information that I can hand out for you to be able to get information about the kit, acquire the kit, but also the landing page online. When you open up the box, the first thing you'll see is one little index card that tells you to go to this URL, and basically from there on, it basically walks you through everything that you need to do to get up and running as quickly as possible. So we're trying to make the experience, flawless. When the developers were working on it, they were actually kidding. This summer, we had one of the youth, I don't even know, I think he's 12 or 13, would come in a lot and sit at one of the workstations in the business and play games, during the day, and they laughed about, that's going to be our tester. When he can do it, then we know we've got it. Maybe it wasn't that funny. We should have, unfortunately, had to go back to grade school. But anyhow, getting started is all about taking advantage of that, point to the URL, and then basically start saying, what do I want to program in? Do I want to do a native, like an app zone, C type of thing? Do I want to do it with Launchpad or Raspberry Pi? And then once you go into that, you're presented with a step-by-step guide, and then all the instructions, as well as all the downloads for the code and instructions on how to download. So try to make it as easy as possible. They're all documented in this format, so you basically, if you've done one, you can very quickly do the others. And if you know hardware, the way they've mapped out the interfaces, the jumpers stay the same between Arduino and TI Launchpad to make things as easy as possible. Clearly, when you move to Raspberry Pi, you have to move some jumpers around, or if you move to standalone. But again, it's all about a quick and simple and successful experience. Like I said, once you're into the code, though, everything is native. If you're an Arduino developer and you're used to using the Arduino IDE, we have a full library for the EVK-4 that's there to help you. You import it, and the next thing you know, there's a working application that connects you to the cloud and basically reads the potentiometers and the push button states, and you'll see it in a minute what it does. And same is true for any one of the platforms. Classically, you'd be working with microcontroller. Those of you that went to the App Zone session have already seen this day, but classically, you'd have your external microprocessor. You do your physical interfacing off of that. You'd leave your cellular module pretty much off to cellular operations, but now that we've exposed a portion of the actual cellular module for what we call our App Zone development environment, you have the capability to, instead of having it on board, move all that right inside the Telit module. So you can effectively, that board can stand alone. It doesn't have a microcontroller on it. It's basically the HE910 or the LE910V2 running your code inside of that. And that would be using, like I said, our App Zone technology. And here you go for those of you who are DeviceWise users that are interested in how you might be able to take advantage of the board as well there for prototyping. You open it right up, you import the application, and you've got the EVK-4 for Raspberry Pi. application. It'll take advantage of the cellular modem on board just like you were running in a cellular gateway. So you'll immediately have a cellular communications up to the network using the same modem driver, but on the Raspberry Pi, it'll be talking through the headers back down to the cellular module to do your communications. So here you see a session established with an IP address that's connected to the cloud. It actually has a 3-bar signal with a RSSI of about minus 87 dBm. So that's what you've got there. If you drill on into that, you'll see that you've got 3 different drivers available to you. Not only do you have your base driver for your system monitor, but now you have a modem data interface, and you also have an EVK-4 interface. The EVK-4 interface actually goes and exposes all the I2C data. So if you go drill into that, you have access to the buttons, the GPI, the LEDs, and all on board, so you can do your standard trigger logic to work with those. If you want to take advantage of the accelerometer or the gyroscope or any of that, you simply tie your triggers to those, so then you can stand there and move your, you can put the battery on it, move this around and see the cube move, in the cloud or what have you want to do. As well as things like the battery monitor. Then you can see basically the temperature of the board, that the energy level, the current signal level, or storage level of your battery, the energy level, or the voltage that it's putting out. So that type of information is all there available to you. Same types of thing at the modem level. What's the ICC ID, what's the IMEI, what versions, software version, firmware versions on the module. All of that information is available to you through that interface. And this is a new feature that we're getting ready to expose in the logic side of DeviceWise, which allows you, once you have that modem channel open, the capability to just send ad hoc AT commands down to the module. We thought that for a developer or a maker, we should open that up so that they also have the capability to call any of the plethora of AT commands that are available to them for the modem, not just what we have available. So now you have a new execute AT command action. And here you can see they were playing with reading the temperature monitor, the analog to digital converter. So you can make those same AT commands directly from DeviceWise and get the interaction as well. What do you see in the cloud? So far we've talked about what's running down on the module or within the prototyping board. Of what you have up in the cloud, we have a pre-built thing definition for the EVK. It has all the button states, the LED states, a predefined set of alarms, things of that nature. Location is on board as well. And as you drill into that, the capability to see the different signals, whether accelerometer, gyroscope, temperature, module temperature. And in this particular scenario, this is for Launchpad. You see they implemented a tap counter using the accelerometer as well. So you can tap it and see how many times someone's tapped the board or the board's been moved, all those types of things you can play games with and all. So those are there available to you in the starter kit as well. Now, once you get up to the cloud, we've also taken care of that too. You've got the thing definition, so the data gets up there. But we also wanted to have a dashboard ready for you too, so you wouldn't have to start from scratch with the dashboard. You could move the gauges around, reorganize things, and take advantage of that too. So also with the Rapid IoT Developers Kit, you have this pre-built dashboard as well that's available. And when you log in, you see this particular one unfortunately wasn't connected to a live unit when I captured the screen. That was my mistake. But basically you can see all the different types of states, or the LEDs on or off. You can turn the LEDs on remotely from the cloud, things of that nature as well. So it basically, this one happens to be for one of the standalone configurations. If you're running a Launchpad or an Arduino, it will actually show that version of the board on the graphic when you're connected. So it basically takes all of that data and makes it available to you in the cloud. So what we've done is effectively given you kind of an end-to-end solution. This is another page that lets you play with the accelerometer, so you know if the board's sitting right side up, face down, on its edge, things of that nature. So just basically allows you to play with the sensors and see some data without having to start from scratch. So that's not all. We realize that since this is going into the hands of makers and developers, it would be kind of short-sighted of us not to allow people to add their own sensors and extend it. So what we did is we made sure that the sensor signals are also pinned out to some of the headers regardless of the configuration that you had, whether you were working with a TI or Arduino or a Raspberry Pi. So your 4 key channels, your serial clock and serial data, and of course power, are accessible for any one of those configurations. So you can very easily extend off board using those pin headers as well to attach your own I2C sensors. This is a simple little circuit diagram that we did for a Bosch BMA150 gyroscope. Okay, so it's a little I2C. We use the TI Launchpad header there, and all of this is available to you in the material that you download. So we've tried to do our homework and make it easy for you to focus on what you need to do. And it looks a lot simpler in practice than it did maybe in development, but that's actually the little accelerometer, the leads going over to the board, hooked to the pins, and you have the ability now to add the I2C address there. You can go in and enumerate your I2C, device address as you see them. You do your I/O control to get the interface to it, and then start sending your register requests. So pretty straightforward. Our target customers clearly come in all shapes and sizes. Classic board developers that are building a board and putting a Telit module on it. Clearly the maker community, where you're a professional maker or an amateur maker working to develop the next IoT solution to change mankind, or a system integrator that really sees the need at some level to interface at a sensor level in a low-cost way, maybe just to get a few signals and get that back into the cloud to be used as part of a much larger solution. So we're targeting those types of customers. We'll be rolling this out in DeviceWise University as well. I think people that come to DeviceWise University today get the Raspberry, the Raspberry Pi and all to take home with you. Later on, you'll actually be taking one of these along with you as well. So you'll get that full experience to work with in class and then and go and use. Lots of use cases. You guys know them better than I do, but it's just the stuff we do. Classic with IoT, whether it's application and environment for agriculture or some type of sensing, smart manufacturing, maybe just some sensory level data. You don't need an entire gateway or something of that nature. Asset tracking, maybe a little bit more advanced than just location, but you're starting to get some real physical signals and all, and bring that in. And then how would this be possibly used with NFC, where you could have a reader or something attached to I2C? Lots of ways to extend and expand on that. And of course, we can support smaller pets now too. You don't have to have that back the entire hardware in the preparation of it. So it allows, and again, batteries on board, monitors on board, so the capability to take advantage of all that's there. So most of the time, I didn't realize Fred was going to pre-announce all this morning. So I figured at the end of the presentation, people would say, okay, enough already. What does it cost, and when can we get one? So at this point in time, the pre-release price is set at $149, and that includes all the pieces, parts, the data plan, the platform plan, the whole package. We've gone over our way to try to make that available to you. If you take a look at kind of competitive offerings that have been out there for a while, they range in price from around $100 to around $200, so we're kind of in the middle of that. We call it pre-release pricing because in the end we may actually be able to bring it down, not bring it up, but we're looking at that right now. So far our runs have been relatively small runs. Obviously we'll change that as things go forward. But a lot of components, a lot of prepackaged value in the software and the pre-configuration so that you can focus on what you want to do rather than doing a lot of the GORP that you have to do the integration. So that's what we're focused on doing and bringing together. I don't know if I have much more than that. No, I think that's pretty much it.